This is the Vika Academy, and we want to do some calculations on Jordan canonical forms. That's the reason my topic today is about canonical forms revisited, because from my previous tutorial I looked on how we deal on Jordan canonical forms. We looked at how we come up with the Jordan blocks, and we saw how they are related with the minimal polynomials. Today we want to look at an example and briefly just look at some of the application of what we know. So this is the example that we have. So suppose that A is a matrix with a characteristic polynomial of this form. Then we want to see whether it can work out for the order of A, and also we get the determinant of that A, and again we see whether we can come up with all possible Jordan canonical forms similar to A. And remember, if you have not actually subscribed to this channel, it's the time for you to subscribe. Just subscribe, and also remember to share with your friends. Let your friends know that there is this good mathematics channel that which is the Vika Academy, which is helping us to revise and get to note some of the key things that we meet in mathematics, be it applied mathematics, pure mathematics, and so on. So this is the home of mathematics. Okay, let's start from the starting point. Now I want to get the order of A. From what we had just discussed from the previous tutorial is that if A is a square matrix, the eigenvalues with lambdas lambda 1, lambda 2, lambda k, or multiplicities m1, m2 to mk, then if we want to get the order of the matrix, we just need to add the multiplicities of the lambdas. And in this case here, if you look clearly, you'll find that the first multiplicity is actually that for the first part. The second multiplicity is this, and the second multiplicity is 1 here. It's only that it's not written. So that now the order of this matrix is actually 2 plus 3 plus 1, which is actually giving us 6. So that's basically the order of A. Mark what we have just done and note it down. It's a quick tip start. What about determinant? What about determinant of A? Determinant, what is our question is, in this x plus 3, x minus 4, x plus 1, what are these? 3, 4, 1 are the eigenvalues. The eigenvalues. So if these are the eigenvalues, it means that their lambdas are these, but what is just coming to change is only 3, 4, 1 is only their signs. Those are eigenvalues. Because eigenvalues are basically the roots. So if you work out for this equated to 0, you get x equal to -3, but they will be repeated because that one is squared, equal to 4, repeated 3 times 4, 4, because it's 2 power 3 is cubed. And those ones are actually what will make the main diagonal of A. What tells us that the determinant is given by main diagonal minus the minor diagonal. So it will imply that then the determinant of A will be actually -3 squared times 4 squared, not squared but it's cubed because it's 3 times 1 negative 1 to power 1, of course. So this is actually giving us negative 576. So that is the determinant of that. So we just need to remember that. You need to remember that the eigenvalue are actually the roots. And where are we going to get the solution for those eigenvalues? When we equate our polynomial to 0. When we equate our polynomial to 0. If you have any question on this point, kindly leave a comment and I will be glad to look at it. Now, next, we are looking at all possible Jordan canonical forms similar to A. So, from what we have here, we see generally the first canonical form possible is minimal polynomial is actually given by the characteristic polynomial for A given here. And because if you look clear in this one, if you look at this px here, you'll see that there is 6 possible combinations. Why am I saying there are 6 possible possibilities? Because of the combinations of the powers. So there are 6 possible m1s. So the m1, the first m1 it will be without the powers, x plus 3, x minus 4, x minus 1, minus 1. And if you see at this one, there's no repetition. If there are no repetition, then A must be diagonalizable, because we have noted that if there are no repeated factors in the minimal polynomial, then the largest Jordan block of size, the size will be of 1. You see, it's power 1, and again we noted that A will be diagonalizable. So the others now follows that it's not diagonalizable. But remember, the question tells us to get the possible Jordan canonical forms. Now we have not checked for this. For this is just direct forward. It is just direct forward, because for this so it will fall like that. M2, if we go to M2 will be, now we square, okay, x plus 3 squared and x minus 4 x plus 1. So in this case here, this one will not be diagonalizable, and this canonical form can be demonstrated as the first block is 2. So A will be like, the first block is power 2, negative 3, 0. Then the others will be 4, negative 1 to be block like that, because the first one is block 2, and so on and so on, so on and so on. So this is basically now the representation to canonical forms. Okay, so with that we can leave it at that point, and now I want you to subscribe and share with your friends if you have not already done so. Until next time.